Hello, welcome. My name is Bryce Simon, and this is my YouTube channel. So today we are going to continue with artificial intelligence and how we can use it to solve our day-to-day problems. Our problem at hand is examination malpractice, and we briefly described the examination malpractice in my previous video, so please you can go and watch the video, like, comment, and subscribe to this YouTube channel. So examination malpractice, as we talked about it in the previous video, it is an act or practice which breaches the rules or compromises with the integrity of an examination. We briefly talked about some of the causes of examination malpractice, and we talked about ways in which students, learners can use to do examination malpractice. So today mainly we are going to focus on data sets and how we can use them in solving this problem. So let's get started. A data set is a collection of related sets of data composed of separate elements, but these can be manipulated as a unit. So data sets, this is data that has been collected by a company or an institution some good time ago, but we can use this data we are basing on it to train our models on how we can. Using data sets, we can train our models through supervised and unsupervised learning techniques on how we can manipulate data, or how we can base on this data that has been already collected by a certain institution to use it in predicting the future and constructing well and proper working model. The dataset selected for this project is the malpractice for GSE and A level. This was done from the UK government in the summer 2017 examination series. So this link below, I will paste it in the comment section in case you want to access the dataset. So let us look at the factors we can consider to select a dataset that we are going to use in this project. We have the quality of data. To construct a well and proper working efficient model, we need good quality data, and this can help us in constructing a model that is more accurate and efficient. So the next factor we consider is file readability. So to select a dataset, you make sure that all the files that are included in that dataset can be read by anyone and they can be accessible in any case. Data integrity. So for data integrity, we are talking about the originalness of data. The contents of the dataset that we selected cannot be edited unless you're the admin or unless you have the administrator's permission. This means that the data remains in its originality, the way it was published by the author. So open integration, this is another important factor, and open integration means that you can use this data, or you can download this data and integrate it in your model. Let's go to the features of the dataset that make it so unique that we can use it for this model. So when you follow that link, we will find out that the dataset we selected, it has a background information, and this enables us to train the model because it has a brief background information which can be used to describe the problem or the model in the model system and to train it to perform a task without any aid or any person helping the model. We have tables in our dataset, and these contain a lot of data, and this data is the one that we shall use to predict the probabilities. We shall use to make our calculations and predict the future calculations. We have the graphs, and these graphs, they are graphical representations of the data, and this can help us to understand more and also to calculate the regression correlation graphs. These ones help us to predict what is coming in the future. We have a report, and this helps to train the model such that in case of any data that has been collected, the model is able to construct a report or to make for us a report about the data that it has fetched. So let's get into the mathematical part of this, and we are starting with Bayes' theorem. Bayes' theorem describes probability of an event based on conditions that might be related to an event. So in probability, it relates the conditional probability and marginal probability of two related events. Let's say you're given the probability of B and you want to find the probability of A. You're able to find it, but can you find the probability of A when you're given B? So that is an example of problems that can be solved using the Bayes theorem in mathematics. But in machine learning, Bayes theorem helps us in training of models, especially in supervised learning techniques of classification and regression. This means that if we have an input and an output, our model should be able to predict what is coming and classify those elements that have already their characteristics existing in our models. So, for example, in the examination malpractice model, the Bayes theorem can be applied in predicting the future malpractice cases given the cases recorded in the past years. There is what we call the Naive's bias, and this is an estimation technique which assumes that the occurrence of a certain feature is independent of the occurrence of other features. So here we look at the independence of a feature from another feature. It is called the bias because it depends on the Bayes theorem. And in naive bias, we compute the likelihood, which is calculated from the test data, hence supervised learning. Naive theorem can be used in face recognition or any other face features such as the nose or the eyes. So this is what we are talking about. In naives, we can look at the facial features, and we use this in recognizing or identifying students that are going to enter the examination room. And we have what we call the Bayesian networks. Bayesian network is a probabilistic graphical model that represents a set of variables and their conditional dependencies through a directed cyclic graph and quantitative components in form of probabilities. So Bayesian networks has two components. It has the quantitative components, these ones we calculate the probabilities, and it also has the qualitative components where we use a directed acyclic graph to calculate and predict the upcoming events. So Bayesian networks they represent a relationship between the cases and their causes. For example, if you have a cause, or if we have a problem that has existed in the past, and basing on the causes, if they start to appear again, we can use the Bayesian networks to predict that this is going to happen, and we are able to fight it or control. Let us get into the differences between the Bayes theorem and the naive Bayes. Naive Bayes theorem can be used for both binary and multi-class predictions and classifications, whereas the Bayes theorem only performs binary prediction. You have seen that the Bayes theorem only performs on operations where we are given one event and we are told to predict another event. But in naive Bayes, we can use it to predict multi-class predictions given other multi-class predictions. We also say the Bayesian theorem allows us to infer the probability of a particular model given observed data, whereas in naive Bayes, it is a type of prediction model which assumes that all features are mutually independent. The difference between naive Bayes and Bayes networks. Naive Bayes network is a restricted form of Bayesian network where you enforce the constraint that the class node should have no parents and that the nodes corresponding to the attribute variable should have no edges between them. While in Bayesian network, the features are selected basing on the scoring functions, which mainly restrict the structure and the parameters using the data. So in case you want to read more about the Bayesian theorem, the naive Bayes or the Bayesian networks. These are provided some of the links here, and I will copy and paste them in the comment section below. You can follow them. So please subscribe to my YouTube channel, turn on the notification for the next video. Thank you for watching.